Hello and welcome to VIA Labs Computex 2022 presentation. The topic of today's talk is going to be mostly about USB 4 marketing segmentation, but we're also going to review the USB 4 spec, and we'll talk about market drivers, and we'll close by talking about the VL830 USB 4 device. So let's get started. So on this slide, we're talking kind of about the characteristics of USB 4. So on the surface level, USB 4's headline feature is that it increases data transfer rates to 40 gigabits per second. And that's certainly interesting, but it's definitely not the whole story. USB 4 fundamentally changes the way USB works, starting with the fact that USB 4 and Thunderbolt 4 actually share the same underlying protocol. So like Thunderbolt, USB 4 functionality requires the use of the USB Type-C connector, and USB power delivery is necessary for the discovery and enumeration process, in addition to power. So all Thunderbolt 4 host systems are actually also USB 4 host systems, although the other way around isn't necessarily true. There are differences in terms of requirements where support for certain features, such as PCIe and Thunderbolt 3 backwards compatibility, are mandatory in Thunderbolt 4, but optional in USB 4. USB 4 and Thunderbolt 4 products are going to coexist on the market, with USB 4 products generally offering a subset of the capabilities of Thunderbolt 4 products. In this way, USB 4 and Thunderbolt 4 are complementary, allowing consumers to choose what's best for their needs. It should also be mentioned that there are differences when it comes to the compliance and logo programs between USB 4 and Thunderbolt, but we're not going to get into those specifics here. In my opinion, one of the biggest benefits of USB 4 is that it has more standard capabilities compared to just vanilla USB Type-C. And this is really going to help reduce end-user confusion and improve their experience. So on top of requiring the USB Type-C connector and support for USB power delivery, USB 4 host systems are also required to support SuperSpeed USB and DisplayPort alternate mode. So hopefully in the near future, laptops with data-only USB Type-C ports are going to be a thing of the past. Hopefully. USB 4 host systems, of course, are also backwards compatible with the existing USB ecosystem. So that includes any USB Type-C cables, devices, hubs, and whatnots that you might have already. Of course, you're going to need USB 4 compliant hosts and devices in order to get the full performance. So when it comes to USB 4 devices, in general, you're only going to get the full benefit when paired with the USB 4 compatible host. But even on older systems that don't have USB 4, they should fall back to either legacy USB or DP-Alt mode. And we've already seen really broad industry support for USB 4. All of Intel's Alder Lake and Tiger Lake mainstream platforms have USB 4 baked in, and that's been the case since around 2019. Late 2019. And Apple, with their M1 silicon, also brought USB 4 support to most of the Mac lineup and the iPad Pro. On the Chromebook side, there are actually several USB 4 enabled Chromebooks today, so it's also a very exciting development. So on this page, we're just going to be looking at how USB 4 compares to previous times when we didn't have USB Type-C. So in the past, basically, when you had different protocols like USB or DisplayPort or PCI Express, you had a single function connector and cable, and they weren't interchangeable. So for example, HDMI works great for video, but you're not going to be able to get meaningful amounts of power out of it. And with regards to PCIe, for most end users, it's really just a board-to-board interconnect between the CPU and storage to expansion cards or maybe graphics. And it's all within the same box. Running PCIe Express outside of the box using cables and stuff is going to be a rather foreign concept for most users, unless maybe you're mining Bitcoin or something. With USB 4, we've been building on this groundwork laid by USB Type-C, and we get to see how we improve the situation. So USB Type-C gave us a standards-based way of using the same connector to use multiple protocols. And this is an example of the USB Type-C receptacle that you would find on a host or maybe a device. So these diagrams are mostly going to be based on a host perspective. So the USB Type-C connector has 24 pins, And of those 24 pins, we have 4 pairs of gigabit speed capable pins. And we've highlighted those here. When used with just USB 3, super speed 5 gig or 10 gigabits per second, we are essentially only using half of the pairs of the cable. So the cable orientation in this case is dictated by the CC pins. So CC1, we're using one side. And if we flip the cable, CC2 designates the orientation, so we end up using the other side. And with the introduction of DisplayPort alternate mode on USB Type-C, we've taken the USB Type-C connector to carry both USB and DP. But the way we do it is we essentially take this one connector and split the wire pairs up so that we use half of it for USB transmit and receive, and then we use the other pair for DisplayPort for either 1 or 2 lanes. So here's kind of a representation of what the Type-C connector looks like when configured into DisplayPort alternate mode. So we have the blue representing USB, and we have the green representing DisplayPort. This is actually a pretty elegant solution for supporting up to a single 4K display and super speed USB at the same time. But as you may know, DisplayPort can actually utilize up to 4 lanes by itself. So in this configuration, our video bandwidth is essentially cut in half. In theory, we actually are able to wire up all 4 lanes of the Type-C connector to support DisplayPort, but then we lose super speed USB functionality. And as a USB guy, we think that's a very sad thing. So one of the drawbacks of this configuration is that we've taken a single connector and we've essentially split it into 2, and each is running its own independent protocol. So we're not actually able to take advantage of a case where we have available bandwidth on one side or the other side. And this is kind of where USB 4 comes into play. So with USB 4, all 4 gigabit speed pairs are actually running the USB 4 protocol. And this is how we support other protocols. So we use something called protocol tunneling, or we'll just call it tunneling for short. So USB 4 can simultaneously support super speed USB, DisplayPort, and optionally PCI Express by essentially wrapping these protocols in USB 4 to allow them to share a single link. So this gives us a common method of aggregating multiple display and data protocols, and we also gain the ability to dynamically allocate bandwidth between them. So in terms of performance, USB 4 offers a minimum of 20 gigabits per second of bandwidth, and the maximum aggregate bandwidth is 40 gigabits per second. It's important to note that since USB 4 is a tunneling protocol, you cannot exceed the performance of the individual tunneled protocols. USB 4 version 1 defines tunneling for USB 3.2, DisplayPort 1.4, and PCIe Gen 3. So although USB 4 is capable of 20 or 40 gigabits per second of bandwidth, if you're only running, for example, super speed USB, you'd still be limited to whatever super speed USB performance levels are. And for most host systems today, that's going to be 10 gigabits per second, although it could be as fast as 20 gigabits per second if the host platform supports USB 3.2 Gen 2x2 tunneling. So in summary, the USB host system is able to aggregate multiple different protocols together, and it transmits them all using USB 4. So on the device side, we actually essentially need to recreate these original input protocols. And a USB 4 device takes that USB 4 data, and it sends out the tunneled USB, DP, and PCIe protocols separately. So on this slide, it's just kind of a summary, and we borrowed this one from Intel, and it basically just states that Thunderbolt 4 and USB 4, they use the same underlying protocol, and Thunderbolt is essentially the most complete version of USB Type-C, and it has a lot of features that in USB 4 are optional. In Thunderbolt 4, they're required. On the host side, we think this actually makes a lot of sense. On the host side, you would want to have broad compatibility with all sorts of different devices, and we think that's great. On the device side, you may not necessarily need to have compatibility with everything, as long as the host side can support it. So this one is just another summary page. We already kind of mentioned that USB 4 is a tunneling protocol. USB 4 and Thunderbolt 4, they actually have the same protocol. And if we look at the theoretical maximum performance, both of them currently can achieve 40 gigabits per second. All right, so now we're going to talk a little bit about the market segmentation. So this is from one of Intel's media slides about the introduction of USB 4, or Thunderbolt 4 rather. So on the slide, it shows a lot of advantages of Thunderbolt 4, but if we look closer at the slide, a lot of the things here are actually the minimum solution requirements. So it is true, Thunderbolt 4 actually does mandate, for example, that the performance of the device has to be 40 gigabits per second. But in USB 4, it's actually also capable of running at 40 gigabits per second, though it's really up to whoever's making the chip, making the device. But a lot of these minimum requirements aren't necessarily super interesting because we actually have the ability to do it in USB 4. It's really just implementation specific. There are things, however, in Thunderbolt 4 that aren't necessarily well defined in USB 4. So for example, Thunderbolt networking and also vPro or active management technology, AMT. So when we start looking at the market segmentation of Thunderbolt 4 and USB 4, we think these are some of the areas basically where Thunderbolt has its own island, so to speak. So Intel AMT, Active Management Technology, and their Endpoint Management Assistant. These things seem to be Thunderbolt specific, and they aren't defined in the USB 4 spec. And these features, they may be important to commercial and education customers. So that's also kind of why we say that Thunderbolt 4 and USB 4 are going to coexist on the market today. So now we'll look a little bit at the USB Type-C market segmentation today. So basically, we have our dongles and adapters, which are just the little things with the stubby cables attached at the end. And if we take a step up, we have these Type-C universal docking stations. So they're based on the same technology, but they usually have more video output ports or maybe more USB and other ports. And some of these are self-powered, so you plug them in the wall, and they're able to charge your laptop or tablet or other device. So the product categories in orange that we've highlighted here, these are essentially all based on multifunction DP or DisplayPort alternate mode. So in general, you're only really going to get 2 lanes of DisplayPort bandwidth. Or if they do support 4-lane, then the USB performance is going to be limited to just USB 2. So in today's market segmentation, if you want better display performance or if you need faster data transfer, you're essentially required to step up to Thunderbolt. So for Thunderbolt docks here, we've essentially called it better than DP alt mode. And of course, buying into the Thunderbolt ecosystem also requires following the Thunderbolt branding rules. And how does USB 4 slot into this? Well, we think at the high end of the market, it's going to exist with Thunderbolt 4. So Thunderbolt 4 in the high end, we essentially define it as customers requiring vPro/AMT, or it's for customers who already have Thunderbolt peripheral devices. And we also define it as for customers who really need PCI Express. So we've already mentioned several times that support for PCI Express on USB 4 is optional, but it's required on Thunderbolt. So that also happens to be one of the key differentiating features. So for USB 4, we actually have a similar video and USB data capability compared to Thunderbolt 3. So we kind of hope that USB 4 can fit in the market as the better than DP alt mode segment. And then if you really need the Thunderbolt peripheral devices or you need PCI Express, then you move up there to the Thunderbolt side. So we've defined this market segment between roughly $150 to maybe $300 as a premium consumer, gaming, and maybe work from home space. So we think of these as USB 4 endpoint devices, or maybe someone will make a USB 4 based dock. And the benefit, of course, is double the video bandwidth compared to DisplayPort alternate mode, and you still get to have super speed USB data transfer speeds. And when we look at where the customers are coming from, we've heard some concern that maybe USB 4 is trying to convert Thunderbolt customers, but we don't really think that's the case. We think that the dedicated Thunderbolt customers who are maybe they're looking for the best, they're have professional use cases, or they already have an existing collection of Thunderbolt peripherals, we firmly believe that they should just stay as Thunderbolt customers. And then for USB 4, we actually have a great opportunity to convert a lot of the existing multifunction DP customers to USB 4 to let them have a better video and data experience. So these are just some of the port and logo guidelines. So USB 4 and Thunderbolt, of course, they have separate logo and compliance programs, and we're not going to talk too much about that here today. USB 4 has this new logo, and they're emphasizing basically the performance. So the USB-IF also seems to be moving away from marketing the spec version, and we hope that towards your communication with your customers that you emphasize the feature and not the spec version. So one of the key features about USB 4 is that it's 40 gigabits per second, and if you look at the certified USB 4 logo, it's highlighted right there. It's USB 40 gigabits per second. So we're not really hanging on to what version of USB it is. And then when it comes to power, they're also highlighting that feature as well. So with the release of USB Power Delivery 3.1, there are new capabilities for charging, and we can do up to 240 watts of charging. We'll be covering this topic in a separate video. So here we're going to be talking about the various types of USB 4 products by spec. So with the introduction of USB 4, some of the terminology is now technical, and it has some particular meaning. So if you do decide to build a USB 4 product, you do need to be very careful about what you call it. So the first class of product we'll say is a USB 4 peripheral device. So this is also where our VL830 falls in. So our VL830, it has a single USB 4 upstream facing port, and we don't have any USB 4 downstream facing ports. We do have USB 3 downstream facing ports, but according to the spec definition, that's essentially an enhanced superspeed function. So USB 4 is a tunneling protocol. We take USB 4 in, we separate USB 3 out, and USB 3 goes to a USB 3 hub. So from a USB 4 perspective, this is still a peripheral device because we don't have any additional USB 4 downstream ports. So in a USB 4 device, you can have other functions such as DisplayPort. So the VL830 has one of those too. You can have PCIe. VL830 did not integrate a PCIe function. And for a USB 4 peripheral device, you can certify at just 20 gigabits per second, and 40 gigabits per second operation mode is optional. So VL830 will support up to the full 40 gigabits per second. Thunderbolt 3 backwards compatibility is optional. And in general, if you want to implement Thunderbolt 3 backwards compatibility, then you also need to have a PCIe function. Because Thunderbolt 3 did not tunnel USB directly, it needs to do it using PCIe. The next two certification categories are USB 4 hub and a USB 4 based dock. USB 4 hub is rather simple in terms of the concept. It's essentially something that has only USB Type-C ports, and all of the ports support USB 4. So the upstream port is USB Type-C and USB 4, and the downstream ports are USB 4, and that's it. So you won't have any A-type connectors, you're not going to have any DPA video outs or anything like that. It's just all USB Type-C, all USB 4. With USB 4, we have a single defined upstream port, so you can't necessarily plug into any port. You're not going to make like a puck with a bunch of ports on it and expect users to wire it up however they want. That's actually not allowed. So you have a defined upstream port, and then the rest of them are the downstream ports, and that's it. So for a USB 4 hub, however, the certification requirements are actually much more stringent. So this thing is required to actually support Thunderbolt 3 backwards compatibility, Most likely, it's going to have a PCIe switch inside. It may need an XHCI host controller, etc. And to take this concept to the next level, we now have the USB 4 based dock. So the USB 4 based dock is essentially a USB 4 product that has USB 4 downstream facing ports, and it has other port types. So you can have some USB type A's for your legacy connections. It could also have a display port or maybe some other video outs. So a USB 4 based dock is a very specific term when it comes to USB 4. So although dock may be kind of a colloquial term and it's been in use for maybe the last 10 years or more, when we're talking about it in relation to USB 4, it comes to mean something very specific. So you're not allowed to call a USB 4 device a dock unless it meets the spec definition of what a USB 4 dock is. So a USB 4 based dock, again, has USB 4 downstream ports. It's required to support Thunderbolt 3 backwards compatibility, and also the downstream ports have to support Thunderbolt 3 as well. Okay, so on this part, we're going to talk about some of the USB 4 market drivers. So in terms of the market drivers today, we see two major categories that are help driving the adoption of USB 4. So one of them, of course, that we didn't list today is the availability of host platforms. So basically, all of the new platforms made by Intel, made by Apple, and also by AMD, they announced their Ryzen 6000 series at CES 2022, and that supports USB 4. So we now have broad USB 4 host, a broad USB 4 host ecosystem. So what about the functions that we can use USB 4 to drive? So a big one, of course, is going to be display. And HDMI 2.1 right now seems to be a pretty hot thing. That allows us to do 8K video outs and also some high refresh rate, maybe 4K 120, for example. Another display technology that has been making the news is a lot of variable refresh rate stuff. So it goes by a lot of different market brands. So VESA has Adaptive Sync. AMD has something called FreeSync. NVIDIA has something called G-Sync. So all of these are essentially variable refresh rate technologies, and it allows the graphics card to send data to the screen, and the screen can display the frame rate depending on how fast the GPU can feed it. So this way it can reduce stuttering and tearing. And lastly, we also have some high refresh rate displays, especially for gaming. We've seen refresh rates now at 144 Hertz, 240 Hertz, and we've even seen 300 plus Hertz refresh rates. And the other segment that we've seen that's been kind of growing is PCIe-based storage, though we're still waiting to see how that's going to impact USB 4. We've seen some NVMe-based storage devices that can currently utilize USB 3.2 Gen 2 by 2, so 20 gigabits per second and super speed USB. And we imagine that those are going to transition to USB 4 pretty soon. So we think that displays are actually one of the biggest drivers for USB 4. So we've created a chart here. It's kind of a rough estimation just to kind of see what we could do with 1, 2, or 3 displays. And we've taken USB 4 in black on the right, and we're comparing it to 2-lane multifunction DP. So 2-lane HBR2, or maybe DP 1.2, and 2-lane HBR3, which is DP 1.4. And we have compared these use cases with no display stream compression, so uncompressed. And then we've also compared them with having compression. So just a note, for the DSC figures, we're making an assumption. We're assuming that DSC can provide us with 3 times the display bandwidth, but the amount of compression DSC provides is a bit variable. And also, DSC is not available on every platform, and on some platforms, they turn it off completely. So you can't necessarily rely on DSC. So with the 2-lane HBR2, we think the best use case for that was for dongles and adapters, where basically you can get 2 1080p 60 frame per second uncompressed. We think that was probably the killer use case. And if you did a 4K, you could just do 4K 30. So that was the previous generation of DisplayPort alternate mode. And with the current generation, with HBR3 support, they can do a single 4K 60 now. And instead of two 1080p's, we can upgrade them to two 1440p's. And right now, we've seen a lot of these two-lane HBR3 products with DSC attached to a DisplayPort multi-stream hub, an MST hub. And in that use case, you can actually get up to three 4K 60s. So with USB 4, one of the most interesting things is without compression, we can do a single 4K 120. So you can do a single high refresh rate 4K. And if we do compression, we can actually get beyond 8K 60. So we think it's roughly maybe 8K 90 or so. And also with USB 4, and this is also why Thunderbolt 4 calls it one of their minimum requirements, is that without compression, there is actually enough bandwidth to do two 4K 60s. So USB 4 can actually achieve that as well. And then if we have three displays with USB 4 Thunderbolt 4, which basically gives us 4 lanes of HBR3, we can do three 4K 120s. So that's pretty incredible. Or we could do an 8K 60 and two 4K 60s. So we kind of think that this is where the future is heading. On the next slide here, in order to drive the displays, you need to have enough of graphics horsepower, right? So one of the trends that we've been seeing is that the integrated graphics that are in PCs and phones and whatnot, they've actually been growing at an exponential rate. You're getting a lot more performance out of the graphics generation on generation than you are with CPU performance. So the blue bar down here is the current Intel 12th gen integrated graphics. And if you compare that to their 10th gen graphics, it's a huge improvement. And then in red here, we have the Ryzen 6000. So the integrated graphics here. So something that's interesting is both of these are maybe 25 watt, 35 watt processors. And if we compare, we are getting comparable performance to a dedicated GPU that was launched just a few years ago. So for example, the NVIDIA GTX 1650 Max-Q, it's roughly a 35 watt TDP. So we're getting roughly this level of performance out of integrated graphics, and that's really amazing. And another thing that's been really helping these integrated graphics solutions take off is these new techniques for smart upscaling or AI-assisted super sampling, etc. So using these techniques, we're actually able to render an image at below native resolution and then upscale them to maybe 4K or even 8K. So we get the performance level of the lower resolution at a high resolution. So something that's interesting to note, for example, is in this particular case, for this game, Call of Duty Warzone, an RTX 3060 Ti, if you enable the DLSS technology, you can get around 102 average frames per second. And that's basically equivalent to what the RTX 3090 can do without the technology. So you have this $400 card and you turn on this magical switch and you can actually meet the native performance of a $1,500 graphics card. So we think that's pretty amazing. And this is not necessarily an NVIDIA exclusive. NVIDIA was just the first with DLSS. And AMD now has FSR and RSR. These are both technologies that they've rolled out. And Intel is developing something called XeSS, and they basically all do the same thing. So for the last part of our talk today, we're going to be talking about the VL830 USB 4 device. So the VL830 is a USB 4 endpoint. We take USB 4 in. We have a USB function. The USB function is a super speed hub. It gives you 5 ports. 4 of the ports are 10 gigabits capable, so super speed 10 gigabits per second. And one of the ports is USB 2 only. And then we also have a DisplayPort out, and that DP out gives us up to HBR3, 4 lanes. So we kind of have a summary here. So the VL830, we're kind of the main target. So docking station, we're using it as a colloquial term here, but essentially it's going to be an endpoint device, or we have multifunction adapter. So the way we use it internally is basically, does this product have a receptacle, or does it have a built-in cable or a captive cable? So in the USB 4 tunnel mode, basically we can do DP 1.4 up to 4-lane output, and we support USB 3.2 at up to 10 gigabits per second per port. And in the legacy mode, which means when we're connected to a Thunderbolt 3 system, or we're connected to just an older DP alt mode only system, in that case, by default, we're configured to DP 2-lane and USB 3 to 10 gigabits per second. And this is our last slide, and this is kind of a summary of the things that we talked about today. So for USB 4 and VL830, we see these as great opportunities for upgrading DP alt mode. So of course, you get the best performance when you're connected to a USB 4 host platform. You're actually getting double the DP bandwidth compared to MFDP, so that allows you to connect to the latest high-resolution, high-refresh rate display monitors. And we think that this is actually a great upgrade and upsell to the existing USB Type-C universal docking stations. In terms of BOM and design, a lot of the universal docking stations with the MST hubs, those parts are actually 4-lane DP capable, but in the MFDP mode, they're only running in a 2-lane configuration. So if you upgrade that front-end chip to a VL830, you're actually getting double the DP bandwidth with a very minimal BOM change. And VL830, if you're connected to a host system that doesn't support USB 4, then we just fall back to the USB Type-C universal experience that everyone knows and loves today. So the USB 4 opportunity, in our opinion, it provides Thunderbolt-like capabilities, but at a new price point. So we've noticed that there is a price gap with Thunderbolt products versus similar DP alt mode and USB products. And that's kind of where we're expecting the opportunity to be. And we feel that end users aren't necessarily looking for cheaper Thunderbolt. They're really just looking for better capabilities versus the existing multifunction DP stuff, and they don't necessarily want to pay a big premium for that. And for most users, they don't really have Thunderbolt peripherals, so they might not necessarily care about PCI Express support or Thunderbolt downstream ports. And lastly, Thunderbolt, we believe, is its own segment. It's a premium brand with a premium price, and it has exclusive capabilities, like we mentioned, such as vPro. And these things aren't part of the USB 4 spec, so it'll be very hard for a USB 4 vendor to offer those types of capabilities. And we think that for USB 4 and Thunderbolt 4, they're going to coexist on the market for a long time. And for existing Thunderbolt users, they're going to keep using Thunderbolt products. So yeah, thanks for listening, and we hope to see you next time. If you have any questions or comments, please send a message to your VLI representative, and we'll see you again soon. Thank you.